simplifying radicals. Okay, so the goal in simplifying radicals is to make the number inside the radical or the root as small as possible. Okay, so the way that we're going to go about this is we're going to think about what factors multiply together to make up that root, remembering that if we get something like the square root 2 times the square root of 2, that would make the whole number 2. So our goal is going to be to pull out pairs, if we're talking about square roots, of the same factor in order to get whole numbers out of a radical. Okay, so the way we're going to do this is we're going to write out factor trees. So if we're looking at number 1, it says the square root of 12. Let's break this down into two factors that multiply together to make 12. For example, 4, 3. So far, we still have no pairs of factors that are the same that multiply together to make a number. So now we keep going. So 3 is the simplest it can get. There's no two whole numbers we could put down here that would multiply together to make 3. 4 we could break down into 2 and 2. Okay, so remember, we're not writing it, but really what we have here is, so if we were going to just write this all out, we have square root of 2 times square root of 2 times square root of 3. All of these together make up root 12. The reason we like this is now we know that root 2 times root 2, that's just 2. We have root 3. So 2 root 3 would be the simplified version of root 12. Okay, so that's the approach we're going to take. We're going to create factor trees and look for pairs, knowing that those pairs multiplied together make the whole number. More, so 48, maybe we go 12, 4. Now we could keep going. So we break down 12, maybe we break that down to 4, 3. Okay, from here we should see two pairs, right? We have a 4, we have a 4. Okay, so really what we have is root 4 times root 4 times root 3 left over. Okay, root 4 times root 4, that's just 4 root 3. That's simplified. You might be thinking, well, what if I had gone further? Did 2 and 2, 2 and 2. Well, 2 and 2 is a pair, 2 and 2 is a pair. So really, we'd have two 2's out in front. I think 2 times 2 times root 3. That's the same thing as 4 root 3. So we end up getting the same answer. All right. So root 28, break it down. Maybe we go 7, 4. 7 can't go any further, but 4 can. 2 and 2. We see this pair. The same number. So we'd have 2 root 7. Try some harder ones. Square root of 320. Well, if there's a 0 at the end, we know that's the same thing as multiplying by 10 without the 0 on there. So 32 and 10. Keep going. Maybe we go 8 and 4. And maybe we go 5 and 2. We keep going. 8, 4, and 2. Okay, now we see some pairs. Okay, so we have a 4 and a 4. 2 and a 2. So really we have 4 times 2 times root 5. It's the only thing that's left over. Simplify that. 8 root 5. Oops. Color. Okay, so again, you could have taken these 4's further like we did in 2 up here, but you're going to wind up getting 2 times 2 times 2 times root 5, which is still 8 root 5. Root 18. Okay, so let's break that down. Maybe we go 9 and 2. That make 3 and 3. 3 and 3. So then that would become 3 root 2. why don't you guys try number 6, okay, and then type your answer in afterwards. Okay, so break this down. If we go to 25, 3. 25, we can break down to 5, 5. Okay, there's our pair. We have 5 root 3. That would be our answer. All right, now we have cube roots. Okay, so remember the idea of a cube root. 3 numbers that are the same that multiply together would make up that number. So like cube root of 2 times cube root of 2 times cube root of 2 would be 2. Okay, so now we need 3 of the same number in our factor tree. So we're still going to create factor trees the same way we did before, but now we need 3 in order to make that whole number. Simplify. So maybe I'll go 4 and 4. Then maybe let's go 2 and 2, 2 and 2. Okay, so now 3 of these together, like what we have here, if we wrote this with the roots, sorry about that, here's freaking out. Cube root of 2 times cube root of 2 times cube root of 2 is what we have here. That makes just a 2 out in front. We'd have 2, and then what's left over, we just have this extra 2. 2 cube root of 2. Cube root of 250. Create our factor trees like we have for other problems. So maybe I'll go 25, 10. I'll go 5 and 5. 5, 2. Well, now we see 5, 5, 5. So remember, this is saying cube root of 5 times cube root of 5 times cube root of 5. Well, the 3 of those together to make 5. And we still have this 2 left over. 5 cube root of 2. That would be our answer. Okay. Keep trying some. Okay, so number 9. Ooh, we have a negative in here. You might be thinking, well, is this no solutions? Well, no, because this is a cube root, right? A negative times a negative times a negative is a negative. So we just know that at the end our answer is going to have a negative out in front. 256 is a tough one. So if you don't know your factors off the top of your head, like personally, I don't know all the numbers to make 256. We do know it's even, so let's just divide it by 2. So we have 2 and 128. Now we got to break down 128. So maybe I'll divide that by 2. 2 and 64. 64, that's 8 times 8. 8, 4 times 2. 8, 4 times 2. 4, 2 times 2. Sorry, guys. 4, 2 times 2. Now I just got to be really careful. We have a ton of 2s here. We have 1, 2, 3. So that's one triplet. Okay, so we have a 2 times. We have 1, 2, 3. It's another one. And then we look at what else we have. We have left over 1, 2. So there's 2 of them left over. So really what we have is times cube root 2 times 2. Okay. So, and don't forget that we have this negative sign here. So this is going to be a negative out in front because we know it's a negative number. So we'd have negative 4 cube root of 2 times 2, that's 4. Okay, so that would be our answer. If we look at 10, again, let's break it down into our factor trees. Actually, why don't you guys try to do this one on your own? All right, see how we do 32 times 10. That's 8 times 4. 5 times 2. Gotta keep going, so we're looking for groups of 3 that are the same. 4 times 2. Still no groups of 3. 2 and 2. 2 and 2. Okay, so remember, we're only looking at the last legs here, so the rest of this doesn't matter. Okay, so 1, 2, 3. So that's 2. 1, 2, 3. Great, we got another one. And then the only other thing we have is a 5 times root 5. For answer, 4 cube root of 5. All right, from here, we have some radicals with numbers in front. We still are going to treat this the same, we just have another number in front. Okay, so we just break down root 72. Let's see, 9 times 8, 3 times 3, 4 times 2, 2 times 2. Remember, now it's a square root. Okay, so now we're looking for pairs. So a pair of 3's, we have a pair of 2's. Now we gotta be careful when we write this. We also have a 6 in front. So it'd be 6 times, so we had a pair of 3's, so 3 times, we have a pair of 2's, then we just have this 2 left over, times 2. 6 times 3 times 2, that's 18 times 2, 36 root 2. That'd be our answer. Okay, let's try another one. So at negative 4 root 54, so let's break down square root of 54. 9, 6, 3, and 3, 3, and 2. Pair of 3's. Oh, so we don't use all 3 because this is a square root. It's be negative 4 times 3 times, left over we have a 3 and a 2. 3 times 2. Be negative 12 root 6. Be our answer. Okay. 13. Now we have a cube root of 135 with 4 in front. Now we're looking for triples. Okay, so 135, since it ends in a 5, we have to think about what multiplies by 5 to make that. Well, that'd be 5 and 27. Let's keep going. 27, that's 9 and 3. 9, that's 3 and 3. Remember, it's a cube root, so we're looking for pairs of, or a group of 3. So 3 3's. So we'd have 4 times 3 cube root of, we have a 5 left over. That'd be, and we simplify, so 4 times 3, this would be 12 cube root of 5. Try one more together. So cube root of 750, tough one. So let's break this down. So we'd have 75 and 10. Keep going. We'd have 25 and 3. 25 could break down to 5 and 5. And break that down to 5 and 2. Now we look for groups of 3. 5, 5, 5. Awesome. We can break out of 5. Now let's write this out. There's negative 8 times 5 times cube root 3 times 2. Let me simplify. Negative 40 cube root of 6. All right. Why don't you guys try to do these last two? You can check your answers. So let's see how we did. 9 times 8. 3 times 3. 4 times 2. 2 times 2. Look for pairs because it's a square root. So we have a 3 and a 3. We have a 2 and a 2. So now we have 5 times 3 times 2 times, we have an extra 2 hanging out, root 2. 5 times 3 times 2, that would be 30 root 2. Last one, now we have a cube root of 128. So let's break down 128. So if you don't know them off the top of your head, divide by 2 if it's even. 2 and 64. Ooh, this is looking better. So 64, that's 8 and 8. 4 and 2. 2 and 2. Same thing for this other 8. 4 and 2. 2 and 2. Okay. We have a 2, 2, 2, 2, 2, 2, 2. It's all 2s. Let's see how many groups of 3 we have. 1, 2, 3. So let's start writing this out as we go. 4 times 2. And we keep going. 1, 2, 3. 2. We have 1 extra 2 at the end. Times root of 2. 4 times 2 times 2. 16. Root 2. Your answer. Okay, that's our lesson on simplifying square roots and cube roots.